Hello, class. I created this video to answer a few of your test questions. So it says we're going to pick two cards randomly from a standard 52 card deck. What is the probability that the first card is a club and the second card is a club? All right, so remember, there are 13 clubs, 13 spades, 13 diamonds, 13 hearts. So if there's 13 clubs, right, 13 out of 52, that's the probability of picking the first card that's a club. And now this is done without replacement. So once I pick that card, there's only going to be 51 cards left in the deck. And there's only going to be 12 clubs left, right? If the first card I pick is a club, well, there's now one less club. So there's only 12 clubs out of 51 cards in the deck. I press enter. And okay, they say round to 3 decimal places. So I'm going to go 0.059. 0.059, first answer. Second, okay, now, what if there's a probability that the first card is a club and the second card is a club, but this is done with replacement. So that means the probability for my first club is 13 out of 52. But now for my second club, well, once I pick my first card, I put it back in the deck and I pick again. So there's still going to be 13 clubs and there's still going to be 52 cards, right? Because this one's done with replacement, meaning I put the card back when I pick. The first one was done without replacement, meaning I do not put the card back into the deck. And this is 0.0625, so we'll call it 0.063. Check answer. Boom, 100%. Next question. How many different random samples of size 5 can be obtained from a population whose size is 39? So this is one of those combination problems, right? So let me just see if right, so this is a combination problem, so it's n choose r. So I could do it by n factorial over r factorial times n minus r factorial. Or, right, I could just use this n choose r feature on my calculator. Right, so my n in this case was 39. So I press 39, and then I hit the math key. I go over to probability. Now again, if I don't have the n choose r, but I have the factorial key, right, that's this little thing that looks like an exclamation point. We can use the formula that's written here. But I do have n choose r, so I pressed 3, and then we pick 5. Now we use this one when order does not matter. Like it doesn't matter, it doesn't have to come in any specific order. I press enter, and I get 575,757. Check answer. Boom, correct. Let's keep going. 14. All right, now you have a lottery where the balls are 1 to 23, but to win you must match 5 balls in the correct order. This order means something. So instead of the combination, we're going to use the permutation formula. We use this one with P when order does matter. We use this one, the combination, when order does not matter. Right? So when I look at my calculator, it's 23 balls. I have to pick 5. So there's 23 balls, and I'm going to use the probability, boom, and it's NP. So instead of the C, we're using the P for permutation, and again, I pick 5, and this is where order matters. So it's 4,037,880. I put that in there, we check answer, boom, 100%, right? And again, if you don't have the NPR or the NCR, you can always use the factorial key, okay? Let's keep going. Number 15. All right, so we got 2 events. So those events E and F are events such that P of E is 0.7 and P of F given E is 0.3. What is P of E and F? All right, so let's get our formula sheet again. All right, so the probability of E and F, well, what's nice is we were given probability of E, 0.7, and we're given the probability of F given E, 0.3. So it looks like we just multiply these two together to get our answer for P of E and F, right? The probability of E and F. So I get my calculator out, and I'm going to do probability of E, which is 0.7, times the probability of P of F given E, which is 0.3. And I end up with 0.21, 0.21. Check answer. Wait for it. Looks like it's thinking. I should get the good job, but the good job never appeared. But just take my word for it. The correct answer is 0.21. Thank you for watching. Have a great day.